right, let's talk about the basics of graphing other trig functions, okay? So not just sine and cosine, but like tangent, cotangent, secant, and cosecant. So what are the main ideas behind those? I pulled this trig table off the internet. I just screenshotted it. Sorry, I should have cited my sources. Don't tell your English teacher on me. But what we want to pay attention to is a couple of things. A, anywhere that there's an undefined on this table, that means that there is an asymptote on the graph. Okay, so that means that there will be nothing that ever crosses there. So think about like the dashed vertical lines, okay? The next thing I want you to notice is in the tangent column, okay, so it only likes to work if you go side to side. Notice that it repeats every pi. So the yellow that I highlighted is the same as the green. So, excuse me, our period has now changed to repeating every pi instead of every 2 pi. So in this pattern, they do not completely repeat until after 2 pi, and then they completely repeat, which is why the period is 2 pi for a basic sine or cosine graph. Tangent is period. Its period is pi, if I could speak. The same will be true about cotangent. Its period will still be pi. And then let's see what happens with cosecant and secant. They're a little different. All right. So I just went ahead and drew the graph because just like in our last lesson, I could make the XY values where this whole column is my X values and this whole column is my Y values and plot those points. Everywhere that was undefined is an asymptote. Now you're saying, hey, the table doesn't have negatives. Well, just think about it going in reverse. Okay, so like negative pi over 2 is actually 3 pi over 2 in a negative direction, right? On the unit circle. And it always looks like this. So these are just the main ideas. Think about what is our domain, what is our range, and we're going to discuss that more in depth, hopefully, but this gets you thinking about those questions. Then notice, again today, we're going to start talking about transformations. So just like last class, you can have vertical shifts, you can have phase shifts, you can shorten the periods, you can have different amplitudes. So be ready for that in class today. In the meantime, let's look at the cotangent function. So again, looking at your table at the top, so if you wanted to pull open the class notebook from Canvas, you can pause the video to do that. It might be the easiest way, but I feel like if I scroll up and down too much, I give everybody whiplash. And so all of my dashed lines are the asymptotes or the undefined parts. Okay, and notice they go in the opposite direction because they are a reflection or the inverse of. Okay, there. Again, we can have everything happen to it. Negative out front, reflecting, I can have that happen as well. Okay, what about cosecant and secant? You'll notice that I have some graphs there and you think, oh, she's already done them for us, and those don't look any different. False. These are just the outlines of their reciprocals. So the pink here is actually sine x and cosine x. Okay, so we're going to see how they compare to the actual secant and cosecant graphs. So if I am looking at cosecant first, I need to know all the places that are undefined. So again, scrolling back up to the top, looking at the undefined places. The undefined places are at 0. And hold on, let me make sure I'm at the right one here. And pi. And that makes sense because that's where sine is at 0 and the reciprocal of 0 is undefined. because 0 over 1 becomes 1 over 0, and we can never divide by 0. Whoops, no. Okay, and if it's at 0, it's also going to have 1 at 2 pi because that's the same location. Okay. So could I make my table values again? Absolutely. But basically it is the reflection of the sine curve going upwards and down and down and up. And this one should go down closer because it does go right along there. Okay? Because the reciprocal of 1 is 1. Okay, again, we will talk about all of the domains and range and asymptotes in class and make sure that we have all that filled out. However, you should be thinking critically about what do I already know and can I figure out some of those values anyway. All right. And same thing for cosecant. Where is it undefined? Or sorry, secant, the reciprocal of cosine. Where is it undefined? And that's at pi over 2 and 3 pi over 2. Again, where the cosine function crosses the x-axis becomes an asymptote. And so then it's the same type of pattern. So it touches the cosines, maxes and mins, but they actually go the opposite way. They are supposed to kind of go a little flatter, but as long as you get the idea. And again, just like everything else, all the things can change. Okay, and we'll talk about some phase shifts and so forth and so on. But these are the basic ideas of how the graphs are created, because I think sometimes in higher level maths, we forget that a graph does have to do with algebra and plugging in numbers. Like that's how we get the graph, is by plugging in a number and getting the output. So the input and the output creates that graph. And so that is how these graphs are created. So this table is really helpful at the top. Sorry if you're going a little dizzy there. Okay, the table is helpful when you think about the radians here being our x values for all of the graphs. Okay, so all the graphs that we did. And then these separately being the y values. Okay, so if you think about that, that will get you through graphing all trig functions.